Right-angled trigonometry. Trigonometry is a branch of mathematics that deals with the relationships between the sides and angles of triangles. In particular, it studies the functions and properties of the three basic trigonometric ratios, sine, cosine and tangent, and their reciprocals, cosecant, secant and cotangent. The basic trigonometric ratios are defined as follows. Sine. The sine of an angle is the ratio of the length of the opposite side to the length of the hypotenuse. Sin theta equals opposite over hypotenuse equals O over H. Cosine is the cosine of an angle is the ratio of the length of the adjacent side to the length of the hypotenuse. Cos theta equals adjacent over hypotenuse A over H. Tangent. The tangent of an angle is the ratio of the length of the opposite side to the length of the adjacent side. Tan theta equals opposite over adjacent equals O over A. SOH, CAH, TOA is an easy way to remember the trigonometry ratios. Hypotenuse, opposite and its adjacent, and angle is theta. Sin theta is opposite over hypotenuse, cos theta is adjacent over hypotenuse, and tan theta is opposite over adjacent. So we can write it as SOH, CAH, TOA. The reciprocals of these functions are defined as follows. Cosecant. The cosecant of an angle is the reciprocal of the sine function. Cosecant theta equals 1 over sine theta. Secant. The secant of an angle is the reciprocal of the cosine function. Secant theta equals 1 over cos theta. Cotangent. The cotangent of an angle is the reciprocal of the tangent function. Cotangent equals 1 over tangent. Trigonometry is used to solve many problems involving angles and distances. For example, it can be used to find the height of a building, the distance between 2 points, or the angle of elevation of an object. Trigonometry is also used extensively in calculus, which is another branch of mathematics that deals with rates of change and integration. Finding missing lengths. Trigonometric ratios can be used to find missing lengths in a right triangle. There are three main trigonometric ratios: sine, cosine and tangent. Each of these ratios relates the length of two sides of a right triangle to one of its angles. To use trigonometric ratios to find a missing length, follow these steps. Identify which angle you are working with and which side length is missing. Label the angle with a Greek letter such as theta and label the missing side with a lowercase letter such as x. Determine which trigonometric ratio relates the angle and the side length you are working with. Remember, sine, cosine and tangent are three main trigonometric ratios. Write out the trigonometric ratio that relates the angle and the side length you are working with. For example, if you are working with the angle theta and the opposite side length x, you would use the sine ratio, as sine is opposite over hypotenuse. Substitute in the unknown values for the other side lengths and angles. For example, if you know the adjacent side length is 6 and the angle theta is 30 degrees, cos 30 equals 6 over x, as cos theta equals adjacent over hypotenuse. Now solve for the missing side length. X equals 6 over cos 30. Then x is equal to 4 into square root of 3. Another worked example. The diagram shows a prism with length 18 cm and volume 253.8 cubic centimeter. The cross section of the prism is a right angle triangle with base 6 cm and height h cm. Show that the value of h is 4.7. The volume of the prism is given and we have to show the value of h. Since volume of the prism is given by the volume equals area of cross section times length of prism. Next is finding missing angles. Trigonometric ratios are used to relate the angles and sides of a right triangle. The three primary trigonometric ratios are sine, cosine and tangent. These ratios are commonly abbreviated as sine, cos and tangent respectively. To use trigonometric ratios to find missing angles in a right triangle, you will need to follow these steps. Identify the right triangle. Identify the right triangle, which is a triangle that has one angle that measures 90 degrees, known as a right angle. Identify the sides and the angles you know. Label the sides of the triangles as the hypotenuse, adjacent and opposite. Identify the angles you know are given. Then choose the trigonometric ratio. Choose the appropriate trigonometric ratio to find the unknown angle based on the information you have. Solve for the unknown angle. Using the ratio and the information you have, solve for the missing angle. Here are the three primary trigonometric ratios and how they are used. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tangent is opposite over adjacent. Worked example. In the diagram, AB and CD are parallel. AD and BC intersect at right angle at the point X. AB 10 cm, CD 5 cm, AX 8 cm and BX is 6 cm. Calculate angle XAB. Here is the diagram. The angle XAB, which is this one. As we can see that angle AXB is a right angle. So ABX is a right triangle. XAB is a right angle triangle and all the three lengths are given. So we can use any of the three trigonometric ratios. Let's use tangent ratio here, which is tangent theta equals opposite over adjacent. So tan equals 6 over 8. XAB equals tangent inverse 6 over 8. So XAB will be 36.86989765 and so on. It's a complete calculator display. Correcting to one decimal place. It will be XAB equals 36.9. So angle XAB is 36.9 degrees. Examination tips. SOH, CAH, TOA, like Pythagoras, can only be utilized in right angle triangles. For non-right angle triangles, use the sine rule or the cosine rule. Additionally, ensure that your calculator is set to measure angles in degrees. Elevation and depression. Elevation and depression are two terms used in trigonometry to describe the angles that are above or below the horizontal plane. Elevation is the angle between the horizontal plane and an object or point above the plane. It is measured as a positive angle from the horizontal plane. For example, if you are standing on the ground and looking up at a bird in the sky, the angle of elevation is the angle between the ground and your line of sight to the bird. Depression is the angle between the horizontal plane and an object or point below the plane. It is measured as a negative angle from the horizontal plane. For example, if you are standing on a bridge and looking down at a river below, the angle of depression is the angle between the horizontal plane and your line of sight to the river. Both angles of elevation and depression can be used to calculate the height or depth of an object or point given the distance from the observer and the angle. These calculations are often used in fields such as engineering, surveying, and navigation. The trigonometric functions used to calculate the height or depth of an object or point are the same as those used for finding missing angles in a right triangle. The primary trigonometric functions are sine, cosine, and tangent. The specific function used depends on the given information and what is being solved for. Examination tips. If the triangles you are interested in overlap, you might want to design more than one diagram. Test yourself. Question 1. ABDF is a parallelogram and BCDE is a straight line. AF is 12 cm, AB is 9 cm, angle CFD is 40 degrees and angle FDE is 80 degrees. Calculate the height h of the parallelogram. Diagram is given, which is not to scale. It's a 2-mark question. Question 2. The diagram shows a rectangle and a diagonal of the rectangle. Work out the length of the diagonal of the rectangle. Give your answer correct to 1 decimal place. Diagram is given, which is not to scale. It's a 3-mark question. Question 3. Here is part of a field. Diagram is given. This part of the field is in the shape of trapezium. A farmer wants to put a fence all the way around the edge of this part of the field. The farmer has 50 meters of fence. Does he have enough fence? You must show all your working. It's a 5-mark question. Question 4. A solid metal cone has radius 1.65 cm and slant height is 4.70 cm. Find the angle that slant height makes with the base of the cone. It's a 2-mark question. Question 5. The diagram shows a field ABCD. Diagram is drawn. The bearing of B from A is 140 degrees. C is due east of B and D is due north of C. AB is 400 meter, BC is 350 meter and CD is 450 meter. Calculate the distance from D to A. It's a 6-mark question.